There's an urban legend you may have heard about an engineer who wrote a command line program to automate his coffee in the morning. Whenever the engineer wants coffee, he runs a script that opens an SSH session to a networked coffee maker and starts walking from his desk to the machine. The script waits exactly 17 seconds, sends the command to brew a latte, then waits another 24 seconds before issuing the pour command. The freshly brewed latte dispenses directly into the engineer's waiting mug. He's timed his walk from his cubicle to the machine perfectly to arrive at the coffee maker just in time. Now, I like coffee, but sometimes I want a burger instead. So in the spirit of this unnamed hacker, let's write a program that allows me to order a burger directly from the command line. If you think about it, ordering a burger is kind of like running a program. Broadly, you want to accomplish one kind of thing, running some operation on your computer or consuming a tasty meal, but there are some details of what you want that might change every now and then. For a command, maybe it's the file to read data from, and for a burger, maybe you're in the mood for onions instead of pickles. This makes a command line program that accepts arguments a good fit for ordering a burger. I'll write my program to take customizations for the burger as command line arguments, representing toppings and sauces. When I run the program, it'll read the command line arguments to determine what kind of burger I've asked for, maybe one with ketchup, cheese, and bacon, and then order the burger. The first argument to my program will be a string indicating what sauces I want. I don't want to type very much, so instead of typing out the full name of each sauce, I'll shorten the designations to one letter. K for ketchup, M for mayo, S for mustard, because M already stands for mayo, and so on. The argument will just be one string, with each character in the string uniquely identifying a sauce, and the program will read each character one at a time to figure out which sauces to add. The toppings will work the same way as sauces, but I have them as a separate argument to cut down on the number of options that share a first letter. I've already had to assign a few ingredients something other than the letter they start with. If I had toppings and sauces in the same argument, M could mean mayo, mustard, or mushrooms. Splitting sauces and toppings into separate arguments keeps the number of possibilities per letter reasonable, so it's less for me to remember when I'm ordering. And actually, let's add a third argument to the program for fries selection. Because, come on, obviously I have to have fries with my burger. Lastly, I'll add multi-burger support, so I can have more than one burger per order. Each -b, followed by the three arguments representing sauce, toppings, and fries selections, will be treated as a separate burger. Great, that's a big chunk of the functionality figured out. I can run the program and pass some arguments, and I'll parse these strings to figure out exactly what burger I want. But how do I get from there to an actual burger showing up on my doorstep? For the actual ordering of the burger, I'll use an unnamed but extremely easy to identify meal delivery service. It doesn't have an API that I can use to submit orders, but it sure does have a website. I can use Selenium to pretend to be a real human and order a burger like a real human would, by clicking the relevant buttons on the website. Manipulating the site with Selenium is actually pretty easy. This company has helpfully included these data test ID properties on many of the HTML elements that I want to click on. So I can just tell Selenium, for instance, find an element that has data test ID property order card icon button, which it can do pretty easily. I don't even have to code out entering my credit card number or my address every time, because I can save that in a Chrome profile that Selenium can load. This is all pretty good. Now let's try it out. You'll see some of the elements highlighted before the program clicks. The first thing the program does is click on the burger section of the menu to jump to that part of the page, so the relevant buttons are in frame and clickable. Once it clicks on the burger to open the menu for choosing toppings, it just loops through the toppings I picked and selects them one at a time. Great, that was the first burger being ordered at 1x speed. I'm going to fast forward through ordering burger number 2 because watching the ordering process a second time isn't much more exciting than seeing it the first time. And we're done. So, amazing. I've just accomplished with hours of coding what it would take a human a whole 30 seconds or so to do. And wait, how much did I actually spend on that? $65 for 2 burgers and some fries? That seems actually a little bit crazy. For comparison, here's the identical order from the actual restaurant's website. Not only is every single menu item's base price cheaper, there's also no service charge. 15%? I can give the driver a bigger tip and still come out almost $10 cheaper compared to that ordering website. So yeah, like me, you probably already know by now that it's nearly always cheaper to order from the restaurant directly, but seriously, this is crazy. Anyway, getting back on track from that gig economy tirade, in just a few minutes the burger shows up at my doorstep, and yeah, it's exactly what I ordered. Pretty tasty. So that's cool, but I just spent a few hours coding to automate a task that only takes a couple of minutes at most to perform. So let's see where this effort ranks on the XKCD grade of automation success to see if this was worth doing at all. And I've wasted more time than I'll ever hope to recover. I guess I should have just stuck with automating my coffee order.